So on your request, what I will do today is I will hold what we have been doing last week, the discussion on functions and graphs and all that. And I will take a short time and I will talk about calculus, that is differentiation and integration, what they mean, why we need it, what we do with it, and how to do it. I will give you maybe after the lecture I will upload a sheet or a PDF or something like that, where you have the rules of differentiation and rules of integration, so that when others are working things out, you can also maybe at least keep the table with you and try to do it. Okay, so I'll give you the okay. Then give me a moment. I need to open a new whiteboard. Your attendance is low. I don't know why that is. If you are already facing difficulties with the so now we talked about functions last time, right? So my approach will be different to how you would typically learn about calculus in a typical calculus course, because I'm right now thinking of a quick way to give you an idea what these two are. And so also in the context of the modules that you have been doing, properties of matter, mechanics, electricity, and magnetism. Okay, so let's try this. I haven't planned it. That's okay. So the topic that we are going to talk about is calculus. Called calculus. In Sinhala, it's Kalanaya. Kalanaya, right? And it has two branches. Calculus is about, now listen very carefully, okay? Try to understand the meaning of these two things, differentiation and integration. So listen very carefully. Calculus is about two, I'm going to use a word, operations. Calculus is about two operations that you can do on functions. Now, you will not find what I just said in a textbook, I'm sure. Okay, so I'm kind of tailoring this to suit you. Okay, calculus is about two, and it might not be like 100% nothing mathematically wrong, but it might not be it's a very different approach, okay, that I'm taking here. Is about two operations. Operations, let me like underline it. Operations, you know, operations, addition is an operation. What do you call it in Sinhala? What do you call operation in Sinhala? Shalya karme neve. In mathematics, we have operations that we do on numbers. Usually, so far, I think the operations you have seen are operations that you do on numbers. Sankhya mata siddha karana මොනවද කියන කර්මද? What do you call it? Give me a good word for Vasinda. මොකද?
ගණිත කර්ම.
Ganitha karma. Good. Yeah, Ganitha karma, right? You have Ganitha karma, එකතු කරන එක, වැඩි කරන එක, බෙදන එක. එහෙම කී Ganitha karma තියෙනවානේ ලඝු ගන්න එක, බලයක් ගන්න එක. ඔක්කොම you take a number or you take two numbers. Some operations are done on one number. මතක් කරනවද එහෙම ඒවා? එක සංඛ්‍යාවක් අරන් ඒක මත කරන්න පුළුවන් Ganitha karmaක් තියෙනවා. නැත්තම් you have operations for which you need two numbers. You take two numbers and add them. You take two numbers and multiply them. You take two numbers and divide one by the other. You can also do certain operations on one number. You can take a number and square it. So squaring, වර්ග කිරීම කියන එක හිතන්න පුළුවන් එක සංඛ්‍යාවක් මත කරන ගණිත කර්මයක් විදියට. So these are operations, right? So you can think of this branch in mathematics called calculus as being something about two operations done on not numbers. Sankhya mata karana operations neveyi mewa. These operations are done on is about two operations done on ewa kaadada karanne done on functions. Done on functions. ශ්‍රිතයකට කරන්නේ function. You take a function, එක function එකක් දෙකක් අරන් කරන එකක් නෙවෙයි. You take a function and you operate on it. You do an operation on it and you get another function. හරිද? දැන් සංඛ්‍යාවක් අරන් වර්ග කරාම එනවා තව සංඛ්‍යාවක්. මම චූට්ටක් ඒක කියන්න. දැන් if you think of numbers, take for example the operation මේ ගන්න උදාහරණයකට come on squaring කියන එක square කරනවා කියන එක වර්ග කරනවා කියන ගණිත කර්මය ගන්න. Take for example the operation that we do on numbers, squaring. Okay, එතකොට ඔයාලට පුළුවන් සංඛ්‍යාවක් ගන්නවා 4 and you square it. මම මෙහෙම කියලා ලියන්නම්කෝ squaring වචනේ ලියන්න. 4 කියන එක වර්ග කරාම you get 16. Right? You start with one number, you do an operation on it, you square it, you get another number 16. Can I start with 16 and go back using another operation? එහෙම operations තියෙනවානේ. You know that addition and subtraction are what operations we say? They undo each other. Addition can be undone by subtracting. Multiplication can be undone by dividing. So those pairs of operations are what operations can we say? ඒවා මොන operations එකද අපිට කියන්න පුළුවන්. ඒ කියන්නේ එකක් අනිත් එකේ මොකක්ද? අනිත් පැත්තට එන්න පුළුවන්. Inverse, very good, right? If you add a 3 to something, you take a number, you take some number, you take some number, you add a 3 to this. You can undo that by taking away 3, subtracting 3. Okay? එතකොට එකතු කරනවා අඩු කරනවා කියන එක reverse operations දෙකක්. Or inverse operations දෙකක්. Similarly, then I'm taking the operation squaring වර්ග කරනවා කියන එක ගත්ත හේතුව තමයි it's an operation done on one number. Addition, subtraction, multiplication, division are operations done on two numbers. You need two numbers to do it. එකක් අරන් එකතු කරනවා කියලා එකක් doesn't make sense. You need two numbers to add. But squaring වර්ග කරනවා කියන එක operation එකක් විදිහට හිතුවොත්, if you think about squaring as an operation, it's a unary operation we say. Unary කියන්නේ එකකට කරන. We have binary operations. Addition is a binary operation. දෙකකට කරන operation එකක්. So here squaring is what you do on one number. When you square it, you get 16. And if you want, you can come back. Right? You can come back. මොකද අනිත් පැත්තට එන ගණිත කර්මය? What is the reverse or inverse of squaring?
Root.
Square rooting. Nikama root kiwot bad, Hashmal, isn't it? Because rooting can be cube rooting, fourth rooting, fifth rooting. Then වර්ග කරනවා කියන එක අපිට ඊට පස්සේ කියන්න පුළුවන් that is English single varga kiwama power 2. If you can take power 3, power 4, gana cube. You take the cube of a number. So I'm only talking about squaring. Varga karanawa, then its inverse operation is square rooting. Then when you start with 4 and square it, you get a unique number 16. Square if you take one number and square it, you always get only one number in it. But now if I come back, if I take 16 and if I square root, if I square root 16, if I take 16 and square root it, do I get back my 4 only, or what happens?
It's just the 4, right?
Just the 4, the
minus 4. Minus 4.
Minus 4 and 4. You get this also, but there is another. So you get 4 and minus 4. Square root karham. I don't know why this keeps happening. 4 and minus 4. So square rooting doesn't give you a unique answer. It gives you 2 answers always, right? Okay, so keep that story in mind because you're familiar with it. And I want you to compare what I'm going to be talking about in calculus with that operation, squaring and square rooting. Squaring gives you a unique number. Coming back, square rooting gives you 2 numbers. Originally, square roots right. Now, calculus, I said, is about 2 operations done on functions. And the 2 branches deal with or studies these 2 operations. So one operation is called differentiation. So think about it as an operation. I want you to think about differentiation. Differentiation, integration, like addition, subtraction. Differentiation. I think it is avakalanaya in Sinhala, and integration. Integration. Anukalanaya in Sinhala. Avakalanaya, anukalanaya. And these 2 are operations done on functions. Function you have a function f of x. Now you are somewhat familiar with functions. We have been talking about functions in the last lecture. Take f one f1 kila subscript f1 kila function ganama. It's just a just to call it as 1 na? f1 f of x I got a 1 first function. Now I can differentiate this function. Differentiate differentiate. Then I get another function. What I get is another function. Another function. I'll call it f2 of x. Okay, so I'm not sure whether, okay, let's see, because I'm doing this on the spot. Right? I'm not prepared for this because it needs to be well thought out, but let's see, okay? So you take a function, you can do what is called differentiation. We'll see how you do it. But you get another function. Okay? Then make a original function, right? Make a function keyword. This is the function I started with, like the 4 I started with squaring. That's the original function I started with. And when I differentiate, the other function I got that I labeled as f2 is called the derivative of that first function. Ara palaveni function එකේ ඒකේ derivative එක කියලා තමයි ඒකට කියන්නේ. බලමු මේ derivative කියන්නේ මොකක්ද කියලා. What you get is the මෙයාගේ derivative එක. Derivative ඒක හරියට derivative of f1 තමයි මේ ආවේ. f2 කියන්නේ the derivative of f1. Right? It's like 16 is the square of the this was the number you started with. This is the original number. This was the original number that you started with. And make it it's the square of 4. හතරේ වර්ගය. ඒ වගේ මෙතන the second function is the derivative. Differentiate කරලා එන්නේ the derivative of the first function. What is f2? What does f2 has any? What does it have to do with f1? And I will also complete this little story here. Then you can now imagine what integration is. Integration is how you can go back from f2 to f1. It's the inverse operation. Now, this is one way of thinking about it. Okay. Integration is the inverse operation to differentiation. So if you take now f2, if you start with f2, this second function, and if you integrate it, you would get not only f1 or square root karahama patangattu or hitumokar ekka saha there is another one wage. When you integrate, you get a family of functions dekak ne metana eno ananta sankhyaවක් including f1 also. Okay, I think up in දැනට ලියමු f1 කියලා, but it's not only f1 and a whole family of functions, එතකොට can I just oops. Are you with me now? You are very quiet. I don't hear anything from you. Are you with me so far?
Yes, ma'am.
Okay. How do I take all these down here? Okay. F1 and a whole family. A whole family. මම කියන්නේ මොකක්ද කියලා තව ගොඩාක් කියව වෙනවා. A whole family of functions. A whole family of functions. And this f1 දැන් මේ අනිත් පැත්තට නාවේ. Okay? f2 ගෙන් f1 ට ආවා. එතකොට the f1 is called දැන් මෙතන මෙයාට derivative කිව්වා වගේ. This is the derivative. f2 is the derivative of f1. f1 is what of f2? 16 is the square of 4. 4 is the square root of 16. The patra kitakin me patra square root. Here f2, f1 was your original function, you differentiated it, you got the derivative function. Now if you start with the derivative function and you integrate and get this back, then this f1 is called, can you suggest? ලස්සන නමක් තියෙනවා, logically ගන්න පුළුවන් නමක් තියෙනවා. මෙයා derivative, මෙයා යාගේ මොකද? අනිත් පැත්තට එනකොට. ඒ කියන්නේ තාත්තයි පුතයි වගේ. Saman is the son of Saman is the son of Pereira. Then Pereira is who of Saman? Saman Pereira ge puta nan Pereira Saman ge kawuda?
Dad.
තාත්තා නේ. ඒ වගේ f2 is the derivative of f1. f1 is what of f2? Suggest kamnada? Abhi say antiderivative. Antiderivative. Prati. Antiderivative. Okay. F1, this is the antiderivative. I don't know why this is happening. Antiderivative. It's okay, like son and anti-son, or dad and anti-dad. Tata puta කියන එක වෙනම වචන දෙයක් නැතුව තාත්තයි anti-තාත්තයි. It doesn't make sense. I mean, not that it doesn't make sense, but it's very weird to say it like that. But එහෙම කිව්වොත් anti කියපු ගමන් ඒකේ අනිත් පැත්තට එන්නේ. එතකොට ඒ තේරුම එනවා. Antiderivative of F2. Okay, right? So this is a bit of terminology, and what these the connection between the operation differentiation and the operation integration. Then බලමු මොකද්ද මේ උනේ කියලා, right? What is the derivative of a function? දැන් මෙතනින් මේක තේරුම් ගත්තොත් derivative, what is this derivative කියලා ආපු function එක. If you understand that, make it automatically you will understand. Okay, so we'll go, oops. Here. Now I'm going to tell you what this derivative function is. Derivative of a function. What is the derivative of a function? How do you find the derivative of a function? By differentiating the function. Function එකක් differentiate කළා තමයි derivative එක ගන්නෙ. මොකද්ද මේ derivative කියන්නේ? Okay? Okay, let's start with the very simple function. ගන්නකො linear function එකක්. Take a linear function. Here's a linear function, a straight line, a linear function. A function in the form y equals mx plus c. Right? It's a straight line. If I ask you this question, what is the gradient? What is the gradient of, we'll say this is y equals 3x plus 4 kilo. Okay, so y කියන්නත් පුළුවන් නැත්නම් මට කියන්න පුළුවන් f of x. F of x equals 3x plus 4. May both notations I will be using. Or notations දෙකම ඔයගොල්ලෝ දැනගන්න ඕනේ for a function. The function is 3x plus 4. When you write it, you can write it as y equals 3x plus 4 or f of x equals 3x plus 4. Okay, two notations for the same function. If I ask you what is the gradient of this f of x, what is the gradient of f of x? Is function එකේ gradient එකයි මම අහන්නේ. Function එකේ. So it's like gradient is a property of the whole function. වගේනේ මම අහන ප්‍රශ්නෙට විදිහට තේරෙන්නේ නේද? මම අහන්නේ ඒ function එකේ gradient එක මොකක්ද? What's the grade? 3. Okay, 3. Gradient is anukramanaya in Sinhala. Anukramanaya. Right? So now since I have given you the equation, you know that the gradient or the anukramanaya is embedded in the equation. It's there in the equation. You just have to look at it and say it. No calculation. If you know the equation of your linear function, now this we have taken a special function. Okay, I've taken a linear function. Rekhiya function, linear function. So when I ask what is the gradient of f of x, you have no problem. You have no issue with the question. You have no issue with the answer. You know the answer. You said it's 3. You said it is 3. And let me just check now. You're supposed to know this, but I hope you know what gradient is. Gradient කියන එකේ තේරුම හොඳටම ඔයගොල්ලෝ දන්නවද? What do you mean by gradient? Symbol of gradient is m. m කියලා තමයි කියන්නේ. m තමයි symbol එක. And m, how do you calculate m? Delta y over delta x the. Can I write like that? Would you be familiar with that? Difference between y coordinates over difference between x coordinates. So you need 2 points to calculate the gradient. If you were to calculate it, you take 2 points on your line. Y difference x difference. Is that right?
Yes, ma'am. Yes, ma'am.
Yes, right. The gradient give me different words that you use for the same idea gradient. Anukramanaya. In Sinhala anukramanaya ni maka kiyanna metana. Okay. There are other words used for the same notion. Gradient කියන එකට වෙන වචන පාවිච්චි කරනවා. මොනවද සමහරය?
Slope of the graph.
Very good. Slope of the graph. And that word is very visual, very graphical. Like slope කිව්වම එන්නේ පින්තූරයක් නේ. බෑවුම. කන්දක බෑවුම කිව්වම ඒක තේරෙනවා. Very steep the very shallow the steep කන්දක්ද මේ බෑවුම ඉතා වැඩි කන්දක්ද බෑවුම අඩු කන්දක්ද බෑවුම. So that's another word. Where do I write it? Well, let me write these other words. This thing is giving me trouble. Because I have your participant window opened on my screen. I have your chat window opened on my screen. I have my little video thumbnail on my screen. So I have to keep moving them, and they get in my way. You don't see that. So if I write again, gradient කියන එකයි slope කියන එකයි එකත් එකම. මේ මොකක්ද වෙන්නේ? Slope what? Slope. I know why that is happening, because my hands are a little, it's warm here, and my hands get a bit sweaty, and then I think that's the problem. That when that comes on the screen, come on in. Slope. Another word, why I'm getting these now. Now you might be thinking, I started to talk about derivative, and now I'm talking about gradient. Hold your horses. Make derivative ends up being something very directly related to the gradient. Okay, so you have to know what gradient is. Gradient is very clearly in order to understand derivative. Okay, so and the reason why I'm picking these other words used for the gradient is because I want you to have the proper understanding of what gradient is. The slope කිව්වම තේරෙනවා. A slope of 10 is steeper than a slope of 2. 10 slope එකක් කියන්නේ නැත්නම් gradient එක 10 කියන්නේ for every one unit you go across your graph, it climbs 10 units up. Gradient එක 10 කියන එකේ තේරුම මේ අතට ඔයා එකක් යනකොට graph එක 10ක් උඩට නැගලා. On the other hand, if you have a gradient of 2, again the slope එක අඩුයි. මේ පැත්තට එකක් යනකොට මේ graph එක උඩට ගිහින් තියෙන්නේ 2යි. Right? I hope you have that idea. Slope. Give me another word, another term for gradient, and this is what is most useful in physics. Coefficient of x. Thariyaди තව කවුරුහරි මොකක්ද කිව්වා?
Tan theta.
Tan theta. Okay, so I will write that. Tan theta කියලා කියනවා. What is theta here?
I don't know how to write it in English now.
අනේ සිංහලෙන් කියන්න.
ඒක තමයි අර මේ අර මොකල්ද? පස්තරේ ඒ ඉර මේ අර x අක්ෂයත් එක්ක ආපාදනය කරන කෝණය.
හරිම හොඳයි. ධන x අක්ෂයයි දැන් අපි මේ linear function එකක ඉන්න හින්දා හොඳයි. හරිද? We are talking about our function is a straight line. So then tan theta Anna right. Dinithi, look at Dinithi's answer. Okay, I'll come to that. So tan theta kiyapakat where theta is the angle between the positive x-axis and your line. That gives you making a gradient. Correct. Okay. And Tharindi said coefficient of x. Ekat may graph hari. For a linear function, it is the coefficient of x. Then මේවා හැබැයි දැන් මේ tan theta කියන එක අර දෙකම එකට මම ලියන්නම්. coefficient කියන්නේ මේක හැබැයි මේ දෙකම හරියන්නේ මේ linear graph එකට විතරයි. මේවා for any function slope gradient කිව්වම it's very general. But tan theta works only for a linear function. Coefficient of x කියන්නේ linear function එකේදී විතරයි. Dinithi says rate of change. I will just adjust your words. මම නිකම්ම rate කිව්වොත් rate ශීඝ්‍රතාවය. Oh my goodness. නැත්නම් rate of change. Rate of change තමයි හරිම වචනේ. Rate of change කියන්නේ වෙනස් වීමේ ශීඝ්‍රතාවය. වෙනස් වීමේ ශීඝ්‍රතාවය. කවුද වෙනස් වෙන්නේ? The rate of change of y with respect to x. That's the proper way of saying it. y ගේ වෙනස් වීමේ ශීඝ්‍රතාවය x ට සාපේක්ෂව. I'll say that in both English and Sinhala again. If you want to write it down, write it down. Rate of change of y with respect to x. In Sinhala, y ge වෙනස් වීමේ ශීඝ්‍රතාවය x ට සාපේක්ෂව. ඒ කියන්නේ when x changes by 1 unit, by how much does y change? x එකකින් වෙනස් වෙනකොට y කොච්චරකින් වෙනස් වෙනවද? Okay, rate of change. So gradient, slope, rate of change, they all mean the same. Okay, then එකත් ඔක්කොම ඔළුවේ තියාගෙන now I'm going to now මේ linear function එකේ හිටියේ හරි සතුටින් හිටියා linear function එකේ. Now take any non-linear function. Linear නොවන ඕනම එකක් ගන්න. Now I'm taking a non-linear function. Quadratic, cubic, laghu, trigonometric, anything other than linear. So they are all non-linear. Linear novana. Now non-linear kipu gamang, what that means is your graph is not a straight line but a curve. Vakrayak tamai or graph එක වෙන්නේ. For example, the man random එකක් අඳින්න හිතන්න මෙහෙම එකක් තියෙනවා කියලා. Right? This is my f of x. I will give you a random. This is not correct, okay? But I will just give you some. This could be 3x cube minus 2x squared plus 4. Right? Or y equals 3x cube. Mama 3 ayin karana datana cube tininda. X cube cube, right? Right. Then can I ask the same question I asked you? I said, what are a linear? What is the gradient of f of x? Can I ask the same question for this function now? Can I ask now? I show you this function. I give you the graph also, and I ask, what is the gradient of f of x? Kawuda f of x meya honde mama me ප්‍රශ්නේ අහනවා. මොකද්ද ඔයගොල්ලෝ මට දෙන උත්තරේ? ඒ ඔයගොල්ලෝ බලලා මේක තියා. It's a curve. What would you say to my question?
It changes from.
It's always changing. Dinithi කියනවා තව කෙනෙක් අචිරාදව දන්නේ අචිරාද දන්නේ. It's always changing. So is there any meaning to my question? Does my question make sense? But the first thing you have to say is, "Hey, prashna therumak nene, madam. Can I ask you what is the gradient of the function?" The function ko mulu ekama. Mulu function ekema gradient kila ahanne eke therumakවත් naha neda. There is no even a meaning to my question. My question itself is wrong to begin with, isn't it? Manga ahu prashne waradhi ne. Waradhi නැද්ද කියන්නකෝ. For the linear function, why was it okay for the linear function to ask that? Because I have turned my laptop around. Why was it okay to ask that question for a linear function?
Because it can be denoted by one value.
Because it can be denoted. Why can it be denoted by one value?
Because the slope is constant.
The
throughout.
slope is constant. Everywhere it's the same. It's the same. It's a constant slope. The slope does not change. Nowhere does it change. Everywhere it's the same. Right? So I can say what is the gradient of the function. Then if I ask what is the gradient of f of x at at x equals 3 කියලා මෙහෙම කැලක් ඇඩ් කරා නම් මගේ ප්‍රශ්නෙට would that still make sense? ඒ කියන්නේ මම මේ ලක්ෂයක් ගැන අහන්නේ. මේ 3 කියන තැන එතනදී මෙන්න මෙතනදී gradient එක කීයද? function එකේ නෙමෙයි මේ ලක්ෂයේදී I'm pointing to a point. I'm pointing to a point on the function on the graph. මෙතනදී බෑවම කීයද කියලා යහන්නේ. Would that also make sense for a linear function to ask? Can I ask like that? Shritaye කියලා නෙමෙයි අහන්නේ මේ ලක්ෂයේදී කියලා අහන්නේ. But would that make sense?
Yeah, it would.
Yeah, right? Because everywhere it's the same. So මෙතනත් එකයි අතනත් එකයි මුළු එකේමත් එකයි everywhere it's the same. Now when you come to a non-linear function, I can't ask the gradient of the function කියලා අහන්න බෑ because from point to the next immediate point it changes. It's not a constant. It continually changes. ඒක නිරතුරුවම වෙනස් වෙනවා. මෙතනින් ඊළඟ තැනට ගියාම වෙනස් වෙනවා. එතකොට මම කිව්වොත් එහෙනම් if I මෙහෙම අහන එක තේරුමක් නැහැ කියවනේ you said that it doesn't make sense to ask this question කිව්වා. So if I slightly change my question ශ්‍රිතයේ කියලා අහන්න නැතුව අර මම at කියලා මම මොකද point එකක් කියනවා. at -2 නා මෙන්න at -2 කියන්නේ මෙන්න මෙතනදී at x equals -2. Now does the question make sense now? Then අඩු ගන්න තේරුමක් තියෙනවද ප්‍රශ්නෙට? Yeah shape වගේ නේද? හරි දැන් එක තැනකදී මම අහන්නේ මුළු එකේම කියලා අහන්න බෑ. එක තැනකදී යනවා. Okay, if it makes sense, how would you answer this? How would you give me an answer to this? How do you find that gradient at that point? At a point, you
draw a tangent to that particular point.
Hashma says draw a tangent. Draw a tangent. It's a subjective. Mama tangent. Can a tangent be drawn 100% accurately? The mom pencil rule tangent. The slope is like that. The slope is like that. The slightly different. So it's a manual method of doing it, isn't it? But it has the idea. I need the slope here. So the slope here is the slope of the tangent line. What do you mean by tangent line? What is tangent line in Sinhala? Sparshakaya anukramane tamai etanadi vakraya anukramane. Right? The gradient of the curve at x equals -2 is the gradient of the tangent drawn at that point. ඍණ දෙකේදී වක්‍රය අනුක්‍රමණය වෙන්නේ ඍණ දෙකේදී වක්‍රයට ඇඳපු ස්පර්ශකීය අනුක්‍රමණය. make sense නේ ඒක අපිට තේරෙනවා ඔව් මෙහෙම කියලා යන අත තියලා බලතයි ඕමනේ වෙනස් වෙවි යන ඕමනේ වෙනස් වෙවි යන්නේ right but how do you like so that's a manual way of doing it ඔයගොල්ලෝ කියපු විදිය නමුත් if you were to compute it now අපිට තියෙනවනේ පොඩි සූත්‍රයක් මෙහෙමනේ gradient එක calculate කරන්නේ right then වැඩේ තියෙන්නේ මෙහෙමයි when I ask you for the gradient at one point එක ලක්ෂයක් පාවිච්චි කරලා මට gradient එක calculate කරන්න බෑ I can't calculate the gradient using one point I need 2 points that's why you are drawing a tangent දැන් tangent එකක් ඇඳලා ඔයගොල්ලෝ මොකද කරන්නේ ඒ tangent එකේ උඩ තියෙන ලක්ෂ දෙයක් ගන්නවා අරගෙන delta y over delta x කියලා හොයන්න පුළුවන් නමුත් ඒ අඳින කතන්දරේ නැත්තම් right when I ask you the gradient at one point you can't calculate it because ඒකෙත් ටිකක් විතර තේරුමක් ගන්න if you think about it if you really think about it ඒකේ තේරුමක් ගන්න බෑ මෙහෙම හිතන අපි actual scenario එකක් ගමු say you're driving a car from some point to another point වාහනයක් උන එලවගෙන යනවා right you're driving so you're moving your distance is changing with time so I can එච්චර දුරට යන්න ඕනේ mechanics වල ඔයගොල්ලෝ ඒක වගේ දේවල් කරන්නත් ඇති now if I can ask you what is your speed ඔයාගේ වේගය කොච්චරද ඔයා කොච්චර වේගකින්ද ගියේ from say you are driving from දන්න තැන් දෙයක් ගමු from Nugegoda to Kirlapana you're driving from Nugegoda to Kirlapana if I ask you what was your speed from Nugegoda to Kirlapana කියලා කිව්වොත් you would take the distance that you traveled and you would divide by the time that you took එහෙමනේ speed එක හොයන්නේ that is finding the gradient of your distance function ඔයාගේ distance කියන function එකේ gradient එක තමයි හොයන්නේ speed හොයනවා කියලා you understand that අපි speed time graph distance time graph එකක් ගන්නකො distance time graph එකක් ගත්තොත් distance time graph දැන් මේ ඇත්ත උදාහරණයකට මම එන්නේ ඔයාගේ y එක distance ඔයාගේ x එක time ඔයා හිතන්නකෝ ඔයාගේ distance එක මෙහෙම වෙනස් වෙනවා කියලා if it is changing linearly හිතන්නකෝ මෙතනදී ඔයා නුගේගොඩ මේ ඔයා නුගේගොඩ මේ time එකේදී දැන් ඔයා කිරිලපන මම ඇහුවොත් නුගේගොඩ ඉඳන් කිරිලපනට what was your speed from නුගේගොඩ to කිරිලපන you would take the total distance and divide by the total time මෙන්න මේ distance එක අරගෙන මෙන්න මේ time එකෙන් බෙදනවා you get the speed but if I ask you what was your speed when you were passing the KFC තියෙනවද KFC එකක් ඒ දෙක අතර කොහේ හරි මොකක් හරි when you were passing the temple අර දැන් නුගේගොඩ ඉඳන් කිල්ලපර නෙවෙයි මං කියනවා පන්සල පහු කරේ මොන වේගෙන්ද කියලා අහනවා so I'm pointing to one point in your journey how would you work that out because to calculate speed you need some distance and you need to divide by the time taken to travel that distance මොකරි පරාසයක් ඉපේ distance එකක් ඉපේ ලක්ෂයකදී speed එක හොයන්න බෑනේ there is no distance there you understand so it's you if you think about it you can't calculate the gradient at one point because for the gradient you need 2 points දෙකක් අතර වෙනසින් gradient එකක් හොයන්නේ right okay so ඒක අපේ පැත්තට කතාව ගියා වැඩිද මන්දා anyway so now we have a problem here the problem is when it comes to a non-linear function whose gradient is continuously changing from point to point how do we calculate the gradient at different points that we want අපිට ඕනම් ඍණ දෙකේදී gradient එක හොයන්න පහේදී gradient එක හොයන්න we might need to do that suppose this is a distance time graph make a distance time graph එකක් නම් මෙතනදී distance time නම් මේ පැත්ත ඍණ පැත්තක් එන්නේ time එකේ මේ දෙකේදී speed එක කීයද පහේදී speed එක කීයද speed is the gradient of this graph so ඒක කොහොමද හොයන්නේ because it's a changing gradient මේ වෙනස් වෙන තැනක එකක් තියෙනකොට එක තැනකදී කියලා හොයන්නේ කොහොමද This is where differentiation comes in. So again, make a yata loku katawak tiyena. You have to talk about the concept called limit. You may have heard of this. Seemawa kiyana ekak pawichchi karala meka godana ganne, but I will not talk about that. So this is where differentiation comes in. Okay, difference eka hadapu vidiya gana man kiyanne, right? What differentiation does is you can take your function, and if you differentiate it, I said you get what function? Make a differentiate karot enne kawudu kiyada man kiye? If I differentiate a function, I get what of that function?
Derivative of the function.
Derivative of that function. Derivative of that function. You know what derivative can be another? I will say derivative in other words. Derivative fancy derivative of the function. What is derivative? In simple words, derivative means gradient at a point. Gradient at a point. Instantaneous gradient. Instant ekakadi gradient eකට තමයි derivative කියන්නේ. So for example, now let me take this function. Okay, දැන් මම නිකන් කරලා පෙන්නනවා. දැන් මේකයි කරන්නේ. දැන් f of x තිබ්බනේ ඔයාගේ. මොකද f of x තිබ්බේ? මම අරන් තිබ්බේ x cube. මම තිබ්බේ x cube minus 2x squared minus 2x squared. මම තිබ්බේ minus 2 plus 4 plus 4. Okay, if I differentiate this, ඊළඟ පේලිය මම differentiate කරනවා. මම වචනේ ලියන්නම්. I differentiate. When I differentiate f of x, the notation is for the derivative. The notation is f prime of x. කියලා තමයි එන්නේ. F prime of x. I know the rules of differentiation. මම දන්නවා differentiate කරන rules ටික. ඉතින් මට මේක කරන්න පුළුවන්. x cube differentiate කරාම 3x squared වෙනවා. minus 2x squared differentiate කරාම minus 4x වෙනවා. plus 4 differentiate කරාම මුකුත් නැහැ. I have differentiated f of x and I have obtained the derivative of f of x, which is f prime of x. Okay, mama y notation එකෙන් ලියුවා නම් මම මේ function එක y කියලා ලියුවා නම් y equals x cube minus 2x squared plus 4 කියලා ලියුවා නම් when I differentiate this, the notation is, remember m is delta y over delta x. When you differentiate, your notation is dy over dx. We read it as dy by dx. dy by dx. dy by dx. dy by dx is the derivative of your y. y ge derivative එක තමයි dy by dx. dy කියන්නේ අර ලක්ෂයකදී චූටි වෙනසක් කියලා හිතන්න. Right? You're in just one point. You don't have a little piece of line to find delta y over delta x කියලා ගන්න line එකක් නැහැ. You only have one point, and it's like you just imagine that you are thinking of the tiniest little difference in y over difference in x. Instantaneous rate of change තමයි එන්නේ. ඒක it's equal to 3x squared minus 4x. Right? The derivative function. You can think of this as a little, what this means is, this is telling you the gradient of your function, original function, at any point you want. ඔයාට ඕන x සමානයි ඍණ දෙකේදී gradient එක හොයන්න නේද? You want the gradient at, I asked the gradient at x equals minus 2 ne? You input, you plug in minus 2 here, you get the gradient. Make your derivative. Derivative gradient at a point. Make you the gradient at a point. So you need gradient at x equals minus 2, then you plug in, you substitute x equals minus 2 in this, you get the gradient of the function, of your Kirby function at -2. Right? So when you differentiate a function, what does that derivative function give you? Derivative function it's like a formula that enables you to compute. Or a tangent and then just to compute the gradient at any point that you want on the curve. Is that clear? දැන් මං පෙන්වෙනා මේ කොහොමද මං කරේ කියලා. How did I get this? There is a set of rules. I will give you those. Then you also would know මං function එකක් දුන්නොත් gradient එක හෙව්වා ඔයාලට ඕන තැනක I'm sorry. You can find the derivative function and then using that you can compute the gradient at any point you want on your function. Okay? එතනට නම් පැහැදිලිද? කතන්දරේ. Is the story clear?
Yes, ma'am.
Okay. තවත් එක්කෙනෙක් දෙන්නෙක් මට respond කරන්න so that I would know.
Yes, ma'am.
Up to there, is it clear?
Yes, ma'am.
Right. Okay. So now in a context of physics, මං ගත්තොත් ඔයාට දීලා තියෙනවා නම් if you are given a distance function, a distance function එකක් x කියලා අපි සාමාන්‍යයෙන් distance function එක ගන්න x of t කියලා ගන්නෙ. So don't be scared of these notations. Then f of x වෙනුවට x of t. X represents distance, t represents time. So distance is a function of time, x of t. So if you are given the function x of t, මොකද මේ x of t කියන්නේ distance function එක. move වෙන යම් කිසි දෙක distance එක කාලයත් එක්ක වෙනස් වෙන්නේ කොහොමද කියන function එක. Say I give you this function, එක t ගේ ශ්‍රිතයක්, t ගේ function එකක්. 2t squared minus t plus 1 කියලා හිතන්න. හරි? If I differentiate this function, මේ distance function එකක්, මේ distance function එක. This is the distance function. Now if I differentiate this function, I get the rate of change of distance with respect to time. කාලයට සාපේක්ෂව distance එකේ වෙනස් වීමේ ශීඝ්‍රතාවය තමයි එන්නේ if I differentiate this. I එන්නේ gradient නෙන්නේ. Right? Derivative කිව්වෙත් ඒකටමනේ. The difference between gradient and derivative is, for the gradient you need a piece of line. පොඩි කොටසක් ඕනේ compute කරන්න. මොකද it is delta y over delta x. But for derivative, it's the gradient at one single point. And then ඔයගොල්ලෝ බලයි කොහොමද මේ formula එක එන්නේ කියලා. ඉතින් ඒ කතන්දරේටම යන්නේ නැහැ. Okay? එක පස්සේ if anyone is interested, you can go and read about it. So if I differentiate this distance function, notation එකෙන් මට ලියත හැකි dx by dt. දැන් මෙතන එන්නේ කොහොමද notation එක? dx, because x is my function, by dt. T is the independent variable. Notation එක අදට පැහැදිලිද? dx by dt. එන්නේ මට මම දැන් differentiate කරොත්, because I know the rules, you still might not know. ඔයගොල්ලෝ තව ටිකකින් දැනගත්තාම එක් කරත හැකි. මෙතන එන්නේ 4t minus 1. දැන් මේ මම මේ ආවේ මොකක්ද දන්නවද? Speed function එක. මේ ආවේ speed එක. This is the derivative of distance. This is the derivative of the distance function. But you know that the derivative of distance is speed. Distance එකේ වෙනස් වීමේ ශීඝ්‍රතාවයට speed කියන්නේ. එතකොට එහෙනම් distance ගේ derivative එකට තමයි speed කියන්නේ. What's the derivative of displacement?
Velocity. Velocity.
Velocity, yes. Okay. You know what? Now, I have differentiated my distance function. Okay. Then I got the derivative of distance. Mata aave derivative of distance. I think derivative of distance එක තමයි speed කියන්නේ. හරි ඔක්කොම එකයි. මම ආවේ මේ. If I differentiate මේකත් function එකක්. If I differentiate that again, මේ derivative එක අරන් මම දැන් ඒක ආයි differentiate කරොත් ඒ කියන්නේ what is the derivative of speed? එතකොට එන්නේ මට derivative කාගේ derivative එකද දැන් මේ එන්නේ derivative of speed. අපි speed නැතුව මෙතන මට ඕන එක ගන්න අපි displacement කියලා පටන් ගමුද? Give me a moment. Let's make this displacement. එතන මේක velocity වෙනවා. That would make better sense. මේක display. මම මේක ඔක්කොම displace. This is a displacement. You start with the displacement function. When you differentiate it, you get the derivative of the displacement, which is velocity. Now the velocity function, if I take, this is a velocity function. Now, dx by dt, v. මේකම තමයි, because I recognize that this is the velocity function v of t. X's derivative is the velocity function. dx by dt is v of t. පැටලෙනවද පැහැදිලිද? Confusing or clear?
Clear, ma'am.
Clear, okay. Now, if I differentiate the velocity function, differentiate කරොත් මොකක්ද මට එන්නේ? I will get the derivative of the velocity. Yes, Bhagya. I would get, what is the rate of change of velocity with respect to time? Velocity එකේ වෙනස් වීමේ ශීඝ්‍රතාවය කාලයට සාපේක්ෂව. That is acceleration. So the derivative of speed is acceleration. I would be getting acceleration here if I differentiate the velocity function. එතකොට දැන් velocity function එක කියලා හිතුවාම මේක notation එක වෙන්නේ මේකෙන් ලියුවොත් dv by dt. දැන් මේ දෙකම එකයි. dx by dt කියලා notation එකෙන්, that notation shows you that it is the derivative of x. කියන එක notation එක ඇතුළේ පේනවා. But it is same as velocity function, so v of t. Now, if I take v of t and differentiate it, it is dv by dt. Right? හැබැයි මම මේ notation එකකින් ලියුවොත් මේක මම නැවත වාරයක් differentiate කරාම, if I differentiate a derivative, දැන් මේ derivative එකක් I differentiate කරනවා. ඒක හරියට 4 square කරලා 16 එනවා, 16 ව I square කරනවා. Right? So x I differentiated x, I get dx by dt. I take dx by dt and differentiate that again. Notation එක මෙහෙමයි පේන්නේ. d squared x by dt squared. හරි මේ ඕගොල්ලෝ බලයි what කියලා. මොකක්ද උනේ කියලා. It's because of square එහෙම ඒ විදිහට එන්නේ differentiate කියන එකේ මේ notation එක ඇත්තටම differentiate කියන එක. Differentiate කියන ක්‍රියාපදය ගන්න, the verb, the action, differentiate. Add කියන ක්‍රියාව, the command එක differentiate this කියන එකේ notation එක තමයි d by dx කියලා විතරයි එන්නේ. කාවද differentiate කරන්න කියන එක උඩින් එතන ලියන්න ඕනේ. ඒතර මම මොකක් හරි දෙසරයක් differentiate කරොත් ඒ කියන්නේ මේක ආපහු ඉස්සරහින් ආපහු d by dx කරාම මට එනවා d squared by dx squared. ඒකින් තමයි මේක හැදුනේ. තේරුණාද දන්නේ නැහැ. So because there is a lot to absorb here, how the notation works and what the concept is. දෙක parallel යනවා, දෙකක් මෙතන. The meaning of the concept and how the notation builds up. I think language එකයි meaning එකයි දෙකම යනවා, mathematical language and the meaning of that. So anyway, so if you track along this x ගෙන් පටන් අරගෙන x of t, x is a function of t. When you differentiate it once, you get dx by dt. If you differentiate it again, you get d squared x by dt squared. Okay, but dx by dt is same as v of t, and second derivative kiyala. This is the first derivative of x. This is the second derivative of x, and it is nothing but dv by dt. You can, if I differentiate that again, I only get 4. But 4 කියලා විතරයි එන්නේ. හරිද? මේක this is actually acceleration a of t. ඇත්තටම මේක t ගේ function එකක් නෙවෙයි, because it's just 4. It's a constant. Acceleration is just 4. It doesn't depend on time. Constant acceleration. මට ඇවිත් ඉතින් මේක of t කියලා කමක් නැහැ ලියුවා. It's a constant function. Okay? I think so. This is how this is applied. Then if I take another one, for example, if you have a function for energy function එකක් තියෙනවා කියලා හිතන්න. කාලය මත. somebody's doing work or work done function, somebody's doing work, okay, or spending energy. So if you have the function, how work is done with time, then කාලයේ ශ්‍රිතයක් තියෙනවා නම්, if I differentiate this dE by dt or dw, අපි work done කිව්වත් energy කිව්වත් දෙකම එකයි. මේ physically මොකද්ද මේ ආවේ? The derivative of energy මොකද්ද? Or derivative of work done is what? Rate of change. Derivative කියලා ගන්නේ හැමතිස්සෙම in a physical meaning, a physical quantity changing with time. So it is a rate of change of that with time. කාලයට සාපේක්ෂව වෙනස් වීමේ ශීඝ්‍රතාවය. මොකද්ද මේ energy වෙනස් වීමේ ශීඝ්‍රතාවය කියන එකට නම මොකද්ද physics වල?
Ma'am, I have a question. So a derivative of something is always with respect to time, or does it change?
It can change, but if you look around and think about physical things, lot of the things are changing with time. Then distance is changing with time. අපිට ගොඩක් ඒවා තියෙන්නේ එම කාලයත් එක්ක වෙනස් වෙන ඒවා. You can have, for example, හිතන්නකෝ rod එකක් තියෙනවා. මේ rod එකේ temperature එක, you are interested in the temperature along the rod, and so you are measuring it according to how far it is. මෙතනින් පටන් අරන් එතන ඉඳන් සෙන්ටිමීටරයක් ගියාම temperature එක, සෙන්ටිමීටර දෙකක් ගියාම temperature එක. So you are talking about the function temperature here with respect to a distance. එහෙම තියෙන්න පුළුවන්, but a lot of the times many of your physical quantities, you are looking at how it is changing with time. If in the context of physics, lot of things are changing with time. Lot of things are functions of time. The rate of change automatically it's a function of, it's a rate of change with respect to time. අපි නිකනොත් ශීඝ්‍රතාවය කොහම අපිට හැඟෙන්නේ, what we feel is how fast something is happening. Isn't it? When you say the word ශීඝ්‍රතාවය, rate of change, when you say rate of change, the feeling that you get is how fast something is happening. That means with respect to time. Somebody's asking something, let me see. Very good. Yes, Bhagya, and I don't know the name of the other person. dE by dt, therefore, that means this is how fast energy is spent with respect to time, means power. Energy spent eke derivative එක power. This is P of t කියලා කියතයි, power. Okay, so keep this in mind. It might not always be your functions might not always be functions of time, but majority of the times බලන්න වෙන exam ඔයගොල්ලන් හම්බ වෙන ඒවා they are functions of time, right? Now is the idea of the differentiation case. So this is differentiation. You take a function, some function that depends on something. When you differentiate, you get its derivative. What is derivative? It allows you to calculate the gradient or the rate of change of that quantity in instantaneous gradient. ක්ෂණික එක මොහොතකදී එයාගේ වෙනස් වීමේ ශීඝ්‍රතාවය හොයන්න පුළුවන්. මේ තප්පරයේදී 10 වෙනි තප්පරයේදී කීයද? What is the speed at the 10th second? කියලා හොයත හැකි. Not the speed from here to here. මෙතන ඉඳන් මෙතනට යනකොට speed එක නෙවෙයි. මෙතනදී speed එක හොයන්න පුළුවන් with derivative. Okay, so derivative is instantaneous gradient, and so that also is a function of your independent variable. ඒකත් කාලයේ ශ්‍රිතය. ඒක නෙවෙයි වෙනස් වෙන තැන්. So if you want to find, දැන් ඔයගොල්ලන්ට ආවද දන්නේ නැහැ මෙහෙම. Okay. So if I talk a little bit about notation, then මම තාම still I didn't tell you how to differentiate. What are the rules? කියලා කිව්වේ නැහැ. Okay. Time is 9:14, but මම හිතන්නේ notation එක ටිකක් වැදගත් වෙයි. If you write a function as y equals, මම කිව්වේ y කියලා ලියලා කිව්වොත් derivative එකනේ dy by dt. I'm sorry, dy by dx. මේක x නම් x ගේ function එකක් නම් මේ තියෙන්නේ, this is your function, this is your independent variable dy by dx. But if you write your function as f of x, okay, if you write your function as f of x, your derivative function notation is f prime of x. See how you read it. Make the f of x. How do you read this? F prime of x. Some people read it as f dash of x. I read it as f prime of x. Mainly, it is read as f prime of x. Then, if I want to find the derivative, if I want to find the gradient, if I want to find the gradient of my function at x equals 3, that means I want to find f prime of 3. Right? F of x is 2x plus 2x squared plus 4 nam. My f prime of x would be 4x. Okay, and if I find f prime of 3, x when x is 3, what is the gradient? It is 4 times 3. 3 it's 12. You understood? Did you understand? If it is clear up to that, we'll take a short break and I will give you the rules of differentiation. Different terms. Kohomada differentiate karanna. Me wage ekak kohomada differentiate karanna. Meka differentiate karanna kohomada. I will give you the rules of difference. If you know them, you just apply them. I mean, that is very mechanical. You don't you don't need to have any understanding about what differentiation is in order to actually differentiate. You could have someone who can differentiate so well, but might not have the tiniest idea what it is about. You now have the idea of what differentiation is about, and you can learn how to do it. How is easy? What it is what is hard. Clear or questions, or if it is clear, we can take a short break. Shall we take a short break, and then I will give you rules of differentiation.
Okay, ma'am.
Okay, thank you, Hashma. Okay, 5 minutes break. Okay, I am back. There was a question from Diniti. Yes, Diniti. Yes, so that's actually another notation that is specially used in physics. Not yeah, it's not very. It's actually a notation that we use due to its convenience. අපි ගොඩක් ඒකත් හිතනවානේ convenience මේ ගොඩ ලියනවට වඩා we like to write something if it can be written in a very short form ne. So for example, now here you have two notations for function and its derivative. If the function is written as y dy by dx, if the function y is a function of x, the derivative of y is written as dy by dx. If the function is written as f of x, the derivative is f prime of x. If you write your function as, okay, y ma gattahama y kiyala tinona function එක for convenience ඔක්කොටම වඩා අඩුයි මේකේ තියන්න. You put a, if you see y dot on top, y dot කියලා එක කියවන්න, y dot, it means the derivative of y. So if you differentiate that again, you can have y double dot. So here in this notation, your starting function is y, its derivative is dy by dx, its second derivative is d squared y by dx squared. Okay. I will just leave the notations here. I'll make up the okay. With the f of x notation, your function is f of x, your first derivative is f prime of x. If you differentiate that again, the second derivative is f double prime of x. So me dash gana වැඩි කර කර යනවා. Okay. So මම මෙතන ලියන්නම් මේ උඩම line එකේ තියෙන්නේ it's the function. Second line is, you can just say derivative or first derivative. පළවෙනි derivative එක. This is second derivative. You can go on differentiating. Third derivative. So second derivative is the derivative of the derivative. Yeah, මුතුන් කිව්වම. Second පුතාගේ පුතා වගේ. Right? මුණුපුරා. මේ තාත්තා නම් තාත්තා එයාගේ පුතානේ. Right? මෙයාගේ මුණුපුරා. It's like that. I mean, you have to understand like how this connection goes. This is the second derivative. Function y, derivative dy by dx, second derivative d squared y by dx squared. Function is f of x, first derivative is f prime of x, second derivative is f double prime of x. In this notation, function is y dot is first derivative, y double dot is second derivative. So if this y, may y කියන එකෙන් අපි තියෙන්නේ displacement නම්, usually x is used for displacement, then x dot is velocity, distance or displacement, x double dot is acceleration. So you would see that a lot, especially in mechanics, I think. Okay, Dinit, is that clear?
Yes, ma'am. Thank you.
Okay. Okay. Now I will show you rules of differentiation. But before that, I really want to ask. Now, the participation today is only 32 students. If I remember correct, last time there were, I'm sure there was something around like 70. I'm not sure. I think I remember like that. Do you remember how many there were last time? And do you know why there is the attendance is low today? Would anyone know?
Ma'am, there are actually only 45 students who are doing the polymer science combination. So out of those students, most of us are here, right?
This is what combination? Polymer science?
Yes, ma'am.
Okay. I'll just find that out. I'm not sure how this works. You know, what like, so are there other students who are like you, who are coming from bioscience stream, who are doing different combinations?
And there are two combinations called C01 and C02 where you can have bio and math students in. And the second combination that does not have physics. It has, if I remember correctly, it's management science and two others, I think forestry. But our combination has physics, so that's why we need maths. But I'm not really sure about the specifics.
Okay, I'll find that out. Right. Okay. Right, so that book that I have given you in the LMS course page, that has rules of differentiation. I just pulled it out now. So I thought I would go, I would show you the book and just show you from there. Where is it? Okay, this is a book that I have given you, and I'm looking at page 92. Okay, derivatives, differentiation starts from, I think, page 87, and you can see, so you can just read this also, right? Say this is the symbol, d by dx is the operator symbol, differential operator. So d by dx means differentiate. That's the symbol of for the operator, and these are the notations I gave you. And we say that, look at this line, we say that dy by dx is the derivative of y with respect to x. Okay, dy by dx means it's the derivative of y with respect to x. කාට සාපේක්ෂවද කියන එක තමයි මෙතන තියෙන්නේ. කාගේ derivative එකද කියන එක තමයි මෙතන තියෙන්නේ. y ගේ derivative එක x ට සාපේක්ෂව. Okay, the derivative of y with respect to x. So y is your function that depends on x. When y is a function that depends on x, the derivative of y comes with respect to x. Here are the rules of differentiation. Okay, the first rule, because okay, so many of the functions that you will come across would be polynomial functions. Now I couldn't finish that discussion. You saw polynomial functions. We couldn't finish that. Anyway, so in polynomials, if you remember, what you have are a bunch of terms of powers of x, right? Now here's your first rule of differentiation. The first rule of differentiation: if you have a function in this form, function in the expression that you have in your function, y equals expression, if that is a power of x, x to some power, suppose the power is n in general, then n could be any power, n could be 2, n could be half, like a power, right? Then the derivative of that is this. If you have x to the power of n, when you differentiate that term, n drops to the, n comes in front, n like a coefficient, n comes to the front and the power drops by 1. Okay, so if you have a function y equals x cube, the derivative of this function is what?
3x squared.
Very good. 3x squared. Okay, the power comes to the front, power as the coefficient, and reduce the power. 3 reduce it by 1. So 3x squared is your derivative. Okay. So there are some examples here. Now I think make the most common kind of term that you can see in a function. So if you take a polynomial function, then if you have a sum of these terms, sum ekak tiyena y equals, say you have can I generalize this rule even more than mama denawana mama ටිකක් මේක මෙහෙමයි දෙන්නේ. I will write the rule in red. If you have y with a coefficient k කියලා coefficient එකක් x to the power of n. ඔහොම term එකක් තියෙනවා නම් if you have a term in this form මේ ආකාරයේ term එකක් තියෙනවා නම් where k is a number, any real number, බිඳුව නොවන බිඳුවනොත් මුකුත් නැහැනේ, k is a real number and n is any real number, any power, like 2x squared, 3x to the power of half, something like that. Then the derivative of that dy by dx is k innawa hemama. Nothing happens to k. K in that the n and isarahata. So k and n gets multiplied together. So it's nk or kn. I can say kn. K hemama tiyala n වෙනවා ඉස්සරහට මෙතන වැඩි වෙනවා. They multiply kn x to the power of n minus 1. එහෙම මතක තියාගන්න ලේසි. මෙතන k එකක් තිබ්බත් මෙතන k එකක් පටන් තිබ්බත් k එක හැම ඉස්සරහ හැම තියෙනවා. Right? So you remember that. So if you have, and then if you have a sum of these terms in your function, වගේ function එකේ මේ වගේ පදවල එකතුවක් තියෙනවා නම්, so for example y equals 3x squared 3x squared minus 2x plus 1 on barma look එකක් දෙනවා මෙතන, right? You just identify that it is just a collection of a combination of or the sum of 3 terms. Each term looks like this. Each term looks like this, so you can apply that rule. For a sum, it's another. There is another rule. තව rule එකක් මේ ගන්නෙ. තව rule එකක කියනවා if you have a sum of this type of terms, you can differentiate each term here. Okay. So if I'm differentiating this dy by dx, what I have to do is I look at each term separately and then differentiate. So 3x squared, what do I get for 3x squared? What's the derivative of this? 6x. Very good. 6x. 6x. Okay, 6x. Then minus 2x. Within a 2x can you know that x to the power of 1. You have x to the power of 1. So minus 2x minus 2x. What do you get when you differentiate? Minus 2 with the I. Very good. Minus 2. Do you all see how that is? 1 comes in front, 1 times 2 is 2, x, 1 minus 1 is 0, x to the power of 0 is just 1. So it's minus 2. And then plus 1. Okay, plus 1 is not this form. May form me plus 1 can x no, there is. You can think of it as having x to the power of 0. 0 තියනවා වගේනේ. This is giving me trouble. You don't see any of it. Different things are popping up here. This is x to the power of 0. It's because my hands are a little bit sweaty. What do you get? It's not x to the power of 6. I can't write properly there. It's x to the power of 0. What would you get? 0. So that means you remember it like this. If you have a number, the derivative of a number is nothing, 0. Derivative and it makes sense. If you have y equals 4 කියන function එක හිතන්න y equals 4. It's a function, constant function එකක්. Graphically it's a line like that, cutting at 4. Cutting at 4, right? What's the gradient of this? What's the gradient of this? What's, because it's a straight line. Zero ne. Hamadaram binduai. So it makes sense. The derivative of a constant is 0, right? So the derivative of this function is 6x minus 2. So this is the most common rule that you will have to apply in differentiating functions, because polynomial functions are the most common type of functions. And may rule lekai, some rule kila thina, some rule it must be there somewhere in this book. Some rule says that if you have a sum of terms, each term individually you can differentiate. So මේ වගේ terms වල sum එකක් තියෙනවා නම් එක differentiate කරලා යන්න පුළුවන්, right? ඉතින් මේක අපි already දැක්කා. This is the මේක තමයි මම කැමති rule එක. අර a එකක් ඉස්සරහට දාලා coefficient එකත් එක්කම you get the coefficient. Okay, now you can see the, okay, let me cover it. What's the derivative of this? I differentiate y equals 4x to the power of minus half. What do you get? Y equals 4x to the power of minus half. What's the derivative of that? Or what do you get when you differentiate that? Minus 2x to the power of Bhagya. Is it half? You have minus half. You have to minus a 1. Minus half minus 1. You have to drop 1. You have to subtract 1. What is minus half minus 1? That's right. Okay, so it is, yes. This 254, index number 254, can you rename it? I requested this on the first day. Please have your profile name starting with your name, please. Okay. The Manatod Kata Karanoni to AS202 2021. But I know 2021 254 here. Okay, so the derivative of this is minus 2, minus 2. Because minus half comes to the front and gets multiplied by 4. So it's minus 2 x minus 1, minus half minus 1 is minus 3 halves. Minus 3 halves. Okay. And here you have an example, a physics related example. If you know Coulomb's law, it describes how the force of attraction between charges diminishes with the distance between the charges. So there is an inverse square, like an inverse square relationship. F is equal to force is a function of the distance between the charges. If you have two charges, so force of attraction, say you have two positive charges, the electric force, the force of attraction between the two charges, the electric attractive force between them is a function of the distance between them. The further apart they are, the lesser the force. I think a square inversely proportional. R squared inversely proportional force. I hope you know what inversely proportional means. R degunayak unot force එක 4 ගුණයකින් බහිනවා. If R doubles, force will reduce by 4 times. By a power by so now here the question is, if we plot a graph of f on the y-axis against r on the x-axis, what is the gradient of the graph? So you take your function is f equals now 1 over r squared can be written as r to the power of minus 2. Now this has that form. Then 1 over r squared. But 1 over r squared is same as r to the power of minus 2. And you can apply that rule when you differentiate. And you get differentiate.
It's a little confusing here. Why is there an equal sign over there? Isn't it supposed to be directly proportional? Because f is equal to q over 4 pi epsilon naught r squared.
Right here, right? There is a constant of proportionality. Do you know this formula?
Yes, ma'am.
Yeah, you know the formula already. Neither. So there must be a constant of proportionality here. What is the constant of proportionality in this Coulomb's law?
4 pi epsilon naught r square.
4 pi epsilon naught.
1 over 4 pi, it is
Epsilon
1
naught.
over 4 pi epsilon naught. And 1 over r squared, right? අපි මේ මුළු එකටම k කියමු. මේක ඉතින් ඒක දැන් this should actually be proportional. මේක වැරද්දක් මේක නේද? දැන් මේක මෙහෙමයි. මොකද මේ කියන්නේ? Decays according to the inverse square of the separating distance r. මෙහෙම හිතන්නකෝ ඉතින් මේක මෙහෙම සූත්‍රයක් තිබුණා නම් f equals 1 over r squared කියලා ෆන්ක්ෂන් එකක් තිබුණා නම් එහෙම ගන්නකෝ. What's the derivative of that function? ඒක තමයි හොයලා තියෙන්නේ. If you have a function f that is equal to 1 over r squared, what is the derivative of that function? And that is this. The differentiation part එක ගැන විතරක් මෙතන බලන්නකෝ. In reality, there is actually a constant of proportionality there, which is that ඒක ආව නම් මෙතන k එකත් එක්කම එනවා. මෙතන k එකකුත් එනවා ඉස්සරහට derivative එකේ. Right? හරි නේද? So if you look at some further rules of differentiation, what I will do is මම මේ ඔක්කොම rules ටික like a table, I will take it to a table and I will upload it into your LMS course page. ඒක බල ඔයාලට ඕන function එක differentiate කරන්න පුළුවන්. Right? These are not to be memorized, but when you apply them a lot of times, you will automatically remember them and you won't need to look at a table. But in the beginning, you can always keep your rules of differentiation table. Right? So the derivative of sine x කියන පදයක් differentiate කරාම you get cos x. Sine x cos x වෙනවා differentiate කරාම. Cos x when you differentiate you get negative sine x or minus sine x. Okay? Don't get scared. You can always refer to these. No problem.
Ma'am, for somebody who doesn't have to refer, how do they learn it?
What do you mean? You
Like
have
for somebody who knows all of this, do they memorize it or do they learn it?
What happens is people memorize this, okay? And even if you don't forcefully memorize them, when you have to apply this a lot, you will have to apply this so many times and you automatically remember it finally. For example, at advanced level, you are required to memorize it. So those who come from mathematics stream, they would already know this. They would by heart karagena tiyenne. If you also can do that, I like loading your memory unnecessarily is something that I really hate. I don't get if you were like my own students. Now this is a course that I'm doing for the physics department for a different degree program, so I can't control everything. But if this was my module that I was teaching at my faculty, I never ask students to memorize. If anyone likes to memorize, yes, go ahead and do that, but not everyone might have a good memory power. It's all about, because when you go to the real world, right, exam exam when you finish your degree and go to the working world, you can refer to this at a phone. There will be a phone with you. You can anytime, if you don't remember, you can Google it. What's the derivative of sine x, right? So I mean, these are not, you shouldn't fill your head with things to be memorized. But what happens is when you apply it a lot, automatically if that happens, bonus, right? But mataka tiyaganna puluwan now, it's good. It's easy for you then. I think it's up to you. So I hope in your, I don't know, in your other courses, whether they will allow you to like at the exam, whether they will allow you to have a sheet with I don't know, so that's out of my control. So,
Ma'am,
but
can we have a few questions to practice?
yeah, sure. So now I don't have anything prepared today. So what I will do is give me 1 or 2 days, by maybe say by tomorrow evening, I will put 2 files, one with the rules and one with questions to practice, to differentiation questions. Okay. The rules I can just give you, but there is one rule called, now these are very direct rules. Direct rules. This term, what you get when you differentiate. Me wage term ekak, me wage padayak differentiate kara wenne mokada. Direct rules, single term rules. These are single term rules. The single term rules. And in addition to this, as I said before, there is a rule called sum rule. The sum rule says if you have a sum of different terms, you can differentiate them individually one by one. Okay, that is sum rule. So for example, if you have a function y equals sine x plus cos x, plus x squared, I have sum of 3 terms. 2 trigonometric terms and 1 power term. What is the derivative of this function? So, the derivative of sine x is cos x. The derivative is of cos x is minus sine x. The derivative of x squared is 2x. Right? So these rules are easy. Single term rules are very direct, and sum rule says if you have a bunch of them, you do it separately. That is easy. There comes a little, I won't say complex, but the other rules that comes are like you might not be able to look at the rule and understand it. I have to maybe explain how to apply that. Then make list the derivative of this term is this, derivative of this kind of a term is this. You can understand by yourselves. But there are some rules called, I will give you the names. Chain rule, I have to explain to you. Product rule and quotient rule. So today we don't have time to dive into that. We have only 5 more minutes. Those 3 rules I will teach you next time. And then I will also tell you a little bit about integration. So integration is the reverse of this. Right? The rules of reverse. But as I said earlier, an integration notation is notation. I think all that we will quickly look at next time. But for today, so oh, you can't do this. You need the chain rule. Yeah, here's another rule. If you have e to the power of x, guess what? The derivative of e to the power of x is e to the power of x itself. This is the only term, or the only function whose derivative is itself. Make the function derivative function so it's like you can remember it like, by the way, do you know what E is?
It's a constant, right?
It's a constant. It's a number. It's a number. It's a fixed number. It's a number like 2. It's a number like 10. It's a number like pi. It's an irrational number like pi. That's why we are writing it using a symbol, because you can't write it down. You know that irrational numbers cannot be written down. Did you know that?
No.
Do you know what? Huh?
No.
Do you know why we write pi as pi? When we want to write 2, 2 symbol flower. Make 2. This is 2. Flower lambda. Lambda 2. Oops. No, you write 2 as 2 because 2 is the number 2. You can write it as 2. But for the number pi, it is, you know, that it is approximately 3.141, it goes like that, or approximately with a very big error, it's 22/7. But the exact number, you write it using a symbol. Pi is a symbol, it's a Greek letter. It represents a number. It's a number. Because you can't write it down. You can't write it down exactly. It's not a number that can be written as a fraction, nor can it be written as a decimal. So if you didn't know that, that type of numbers are called irrational numbers. They are numbers that cannot be written down. If you write the decimal form of it, what happens is it's 3.141 and it goes on forever. It doesn't repeat. It has no pattern. So using computers, we have figured out digits of pi to so many, I mean, like 1,000 and so many digits, but it's not a number that ends. Even when and you can't write it as a fraction. There is no exact fraction that represents this. It's a fraction decimal. Then, so that's why you use a symbol for it. But the symbol represents it's an exact number. Exact number. So those are called irrational numbers. And E is a number like that. And just like where pi came from, pi is related to a circle. It's the ratio between the circumference and the diameter of a circle. Pi කියන්නේ වෘත්තයක පරිධියයි විෂ්කම්භය අතර තියෙන ratio එක වගේ ඒකේ embed වෙච්ච constant එකක් නේ. ඒ වගේ E කියන්නේ nature එකේ තියෙන constant එකක්. ඒකටත් මම I will try to post a YouTube video. ඒක ගැන මම ගොඩ කතා කරන්න යන්නේ නැහැ. What that is, it's an irrational number. It pops up in the nature. You know, these growth functions, population growths, diminishing functions, monahari naturally decay vena eka, nathang vardhane vena eka, growth or decay processes happen. There is a connection between that and this number E. It's an irrational number. So that comes up in a lot of places. So you can remember that the derivative of e to the power of x is e to the power of x. Because E stands for exception. It's an exceptional function. It's the only function whose derivative is itself. Okay, I think it's 9:59. I will send you these basic rules, except the 3 rules I told you: chain rule, power rule, and quotient rule. Sorry, chain rule, product rule, and quotient rule. Next week. But I hope that with what you saw today, you would at least cope with the things that you would be seeing in the other modules. And I'm glad that you told me about it. I would try to talk with these lecturers and like see what they are, what's coming up, so that I can prepare you for that. Okay?
Ma'am, so for other irrational numbers also, there are when you differentiate other irrational numbers, would they also?
No, just E. Just E to the power of x is e to the power of x. E is the exceptional number. Not any irrational number. E, only for E, its derivative is itself.
Okay, ma'am, thank
Okay,
you.
good.
And also another thing.
Good question, yes.
And also another thing, ma'am. So last week we didn't have lessons because it was a POIA. Yeah? So exactly on the same day, we also had a physics course called Waves and Vibrations. So we've only done 1 class so far. So we have that lecture today. So maybe we might be doing maths parts in that course as well. So if you could talk to that lecturer as well, it would be great. Just give me a moment. I think so. I'm not sure. Just give me a moment while I just check.
Yeah. I think it's done by him.
It says here SK.
Yeah, Professor Shanta.
Yeah.
So it's your first lecture today.
A second lecture.
Second lecture today.
Professor Shanta Gamake. Yeah.
Yeah. Um, okay, I would like to arrange an extra lecture for the one we missed, but we don't have much time now to discuss that. Quickly let me know, do you have any free slots during the week? Or is it full?
Ma'am, we do have free slots. So on Monday from 4 to 6 we're free. Tuesday 1:30 to 3:30, that slot we're free.
1:30 to 3:30.
Yeah, ma'am. Then on Friday we are free from 8 to 12:30, the full time.
Okay. So if I'm, I will have a look at these slots, whether I can fit one to one of these. And if I'm doing that,
But ma'am, this is for the polymer science combination, so I'm not sure about other
there might be other people.
Yeah.
Yeah. So I have to find that out too. So yeah. So I will. Okay. Let's do that next week. Okay. Let's talk about that next week. Thank you, Chamodi, and you're putting that directly to me. So others might be wondering what I'm talking. Anyway, so everyone, I hope what we did today was clear to you. It's 10:02. I've taken 2 minutes extra. I will see you next Wednesday, and I will upload the things that I promised you that I will upload by tomorrow evening. Okay. Please don't get discouraged if you see maths that you have not seen before. I'm sure that you can manage it with this course. Okay. Okay. So good luck and take care. I'll see you next week.
Thank you, madam.
Thank you.
Thank you, madam.
Welcome. You're welcome.